So in this lesson, what we're going to do is we're going to talk about how roots and exponents are related. And a rational exponent just means that the power or exponent is a fraction. For example, if I had something like 5 to the 2/3 power, the thing that is the rational exponent is this power right here, because it's a fraction. So that's all it means. And a little bit ago we talked about how when you see something like the 7th root of x cubed, this really means the same thing as x to the 3/7 power. And so what you need to be comfortable with is going back and forth between radicals, which are those root symbols, and rational exponents, which are the exponents that have fractions. Because we're going to be doing that from now on in math. We'll use both. And down below, in the bubble, they talk about it in its general sense with letters. So like, for example, what you'll see is that it says an A, that's the base, like our X up above in blue. And it has an M and an N. And the M is like the 3, and the N is like the 7th. And they're showing how that works as a general rule. And as long as you kind of understand what the blue is saying, that's the main idea for today. So let's look at some common examples. X to the 1/2 power is like saying the square root of X. And the crazy thing is we don't really write the 1s and the 2s, but they're there. So even though we don't write it, there's a 1 for the exponent inside the radical, and even though we don't write it, there's a 2 in the crook of the radical saying that it's the square root. So we always know that there's a power of 1 there, and we always know that it's a square root unless we see something different. It's just kind of understood. When you get to something a little bit different, like x to the 1/3 power, that's talking about having your x again, but this time the root is a 3 and the power is a 1. So the number on the bottom is the root, and the number on the top is the exponent. And then the last one is where you have a power of 3 and a root of 2. Now if you're writing these on your calculator, for example, if you want to do x to the 3/2 power, on your calculator what you would write would be x and then a caret and then a parentheses and then a 3 divided by 2. So this last part here, the part that you see after the caret part, is how you enter in fractional exponents on your calculator. The top number always goes first, the bottom number always goes second. There's a division symbol in between them in a parentheses. And we'll do this in some of our examples. So I'm going to show you how to do some things with the calculator, and then I'm going to show you how to do them without. So in case your calculator ever dies, you can do it both ways. So let's take a look at our calculator first. Bless you. What the craziness? That we see. We have 27 to the 2/3 power. On your calculator, you would type in 27, the little caret symbol, and then you would go parentheses 2 divided by 3 parentheses, and then hit enter. Boom, out pops the answer, 9. Now most people struggle with the algebraic way to do it, so I'm going to concentrate mostly on that. So you saw in the calculator how we did that by typing it into the power, but now I'm just going to most of the time just work on the screen here with algebra in order to do these problems. So 27 to the 2/3 power is really like saying that I want the square root of, or sorry, the cube root of 27 squared. And then if I know that inside here, this 27 can be written a different way, then I can simplify this a little bit. So what I can do is I can leave it as the cube root, but 27 is really like 3 to the third power. That's that highlighted yellow stuff. Because 3 times 3 times 3 is 27. And then, after that, I know that that was being raised to the second power. And last week we learned that when we have a power to a power, we multiply the exponents. So this is really like saying the cube root of 3 to the sixth power. Now you might ask yourself, well, okay, what does that really do for me? But now if I go back to the rational exponent, the fraction, this is really like 3 to the, and then the power would be 6 over 2. Because the exponent goes on top and the root goes on the bottom. Bless you. Sorry, I meant to write a 3 instead of a 2. Thank you for pointing that out. So it's 6 over 3. And if you know what that means, that means you really have 3 squared, which is the 9 that we found on our calculator. So whether you have a calculator or not, you can do this problem. You don't necessarily have to have a calculator to do it.
So if you just did 3.
So this next one we have 8 to the 5/3. If I start out kind of the same way, that means that I have the cube root of 8 to the 5th power. And I know 8 is 2 times 2 times 2, which is the same as 2 cubed. So this is really like saying the cube root of 2 cubed to the 5th power. And this 8 is the same as this 2 cubed. And then from our previous example, what that means is I really have the cube root of 2 to the 15th power. Because you multiply the exponents when you have a power to a power. And then if we rewrite that in its rational form instead of the root form, that means 2 to the 15 over 3, which is 2 to the 5th power. And then all you'd have to do is multiply 2 out 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And that would be your final answer. So the main idea is to try and go back and forth between roots and rational exponents. In number 3, there's a different way to do this besides going back and forth between the roots if you recognize something. So for example, what I recognize is that 16 is a 2 power thing, like 2 to the something, 2 to the 4th power. And I also notice that I have a 4th root. So what I would do instead of going back and forth between the radicals is sometimes I find it to my advantage to go like this. 16 is 2 to the 4th. And I'm raising that to the 7/4 power. So this thing on the inside, this 2 to the 4th, that's my 16. 2 times 2 times 2 times 2. And then already I'm at the situation where I have a power to a power. And what do you do with those things? You multiply them. So 4 times 7 is 28. 28 divided by 4 is 7. This is really like saying 2 to the 7th power. And we already learned in the previous one, in the purple, that 2 to the 5th power is 32. So now I have 2 more to go. So 32 times 2 is 64. 64 times 2 is 128. And I just multiply that out. Okay, and the next one, recognizing that each of these, if you're able to do them by hand, or for the most part by hand, have to be some kind of power thing. 32, we found out in problem number 2 in the purple, is 2 to the 5th power. So I know that that 32 is 2 to the 5th. And I can't, what is that? Does that say 0.6? 0.6 is the same thing as 3/5. So they're asking you to recognize 2 things at the same time. One, they want you to recognize that 32 and 2 to the 5th are the same. And 2, they want you to know that when you see something in a decimal format, 0.6, that can also be written as a fraction format, 3/5. When I multiply the power to a power, nobody's going to know why we're laughing. It's great. 5 times 3 is 15. Divided by 5 is 5. Or you can know that the 5's cancel out. And really what you end up with here is 2 cubed, which we have talked about before is the same thing as 8. So in number 5, maybe you don't know that 2.5 is 5/2. And you're going, oh my God, how am I supposed to know that? So we'll start out with percentages. So in number 5, there are 2 parts. Number 1, I know that 9 is the same as 3 squared. And 2.5, I'm not really sure what that means as a simplified fraction. So maybe I start out with that's 250 out of 100. Because whenever you see decimals, if you change them into percentages, like 250%, you just move the decimal a couple places and put it over 100. And so maybe this isn't the fastest way to do it, but it might be a way to think about it. And again, not to forget that the 9 came from the fact that we have this 3 squared here. That's what it turned into. And I'm also choosing to make the 2.5 the same thing as 250 out of 100. Again, not the only way you can do it. So then if I simplify this a little bit, I can make that 3 squared on the inside. And the zeros can cancel out, so I could really have 25 over 10 as another step. And then I know that 5 goes into 25 5 times. 5 goes into 10 twice. So this is really like 3 squared again on the inside to the 5/2. And whenever we have a power to a power, we multiply those exponents. So this is really like 3 to the 5th power, because the 2's cancel out. Because 2 times 5 is 10, divided by 2 is 5. And 3 to the 5th means that we have 3 times 3, which is 9. 9 times 3, which is 27. 27 times 3, which is 81. And 81 times 3, which is 243, I believe. So let me check my math.
Yeah.
Now, in these next 3 examples, we're going to use what we just learned about rational exponents, that means the fractions,